Welcome back to SCBCNS, the Scientific Collaborating Broadcasting Circle News segment, the news channel that gives you all the latest news about what's happening around the world. Please welcome our special guest for today, Fred Allen, a world-renowned scientist and a respected figure in the science world. Now tell me, Fred, what are we discussing today? What's the topic?
Now I will tell you, John. It's certainly exciting and it's definitely interesting, but also it's quite scary since the topic for today is ETM. Now, for anyone who still hasn't heard of ETM, it's an asteroid that is estimated to hit in just 42 days.
Yes, an asteroid certainly does sound quite scary, Fred. But I'll represent the public and ask, what do you mean it's going to hit in just over a month?
Smell a segue, shall we?
So, what on Earth is ETM? Well, first of all, it's not on Earth, it's in space. It's an asteroid in space with a trajectory that's aiming straight at us. And I'm not kidding when I say it's big. It's also moving fast. Well, big and fast. Let's ask our man at the sea, Bill.
It's my turn. Right. Yes, John. Thank you. So, specifically, the asteroid ETM has a mass of 6.89 times 10 to the power of 15, or 6,890,000,000,000,000 kilograms while moving at the speed of 103,450 kilometers per hour. It is 104.7 million kilometers away from us, so if you do the math, we likely only have around 42 days before contact is made. If we do some more math using that information and Newton's second law, which states that force equals mass times acceleration, we can discover that ETM currently has a force of 1.9799181 times 10 to the power of 20, or 197,991,810,000,000,000,000 newtons. Just to give a better idea of how big ETM is and put into perspective how much damage it will really cause if we fail to prevent it or at least ease the collision, we all know about the Chelyabinsk meteor that happened in 2013, destroyed over 7,000 buildings and injured at least 1,000 people. It was only 654 kilograms in mass and moving at 68,400 kilometers per hour. That's not very small or very slow, but its size and speed is laughable if we compare it to ETM, whose mass is around 10,535,168,000,000 times bigger, and whose speed is around 1.5 times faster. Not to mention, the force of Chelyabinsk was only 1.2426, which is equal to about 0.0006276,017% of ETM's force. Back to you, John.
Thank you, Bill. Now, I'm sure most people can relate an asteroid to a disaster. But why exactly would an asteroid be disastrous? I mean, obviously, it's because big rock crashed on the moon. Oh no, big boom, Why asteroids can cause so much damage? We know that because the disaster has happened before. 65 million years ago, a massive asteroid hit the planet Earth, which most notably wiped out the historic species we know as dinosaurs and then some others. But how do we know about what happened? We know that because the collision left evidence that we were able to use and figure out what the asteroid did.
Evidence was found among fossils, dirt and rock layers, and even in records of species diversity over time. In rock layers that formed 65 million years ago, iridium and quartz material commonly found in asteroids were discovered showing up a lot that confirms the existence of an asteroid. In the dirt layers, a significant amount of soot was found suggesting that the asteroid had caused a massive forest fire. Furthermore, in both animals and plant fossils, many species went extinct, causing a massive dip in species diversity. And that points to there being a mass extinction, which then supports the theory of an asteroid waltzing through, just destroying everything.
That's interesting. Also, I heard somewhere that an asteroid collision could cause an earthquake, or I think it was a tectonic plate movement. How correct is that?
That's a good question. Most asteroids aren't big enough to cause anything more than just a small tremor, but it's assumed that the dinosaur asteroid was big enough to puncture all the way through the crust and to the mantle. However, there have been no recordings of an asteroid causing an earthquake ever, so it is purely theoretical. Essentially, if an asteroid is big enough, it could cause tectonic plate movement, which then causes other disasters like tsunamis, earthquakes, volcano eruptions, etc.
What about with ETM? Is ETM big enough to create more than just tremors?
Another good question. Well, ETM size is pretty close to how big we assume the dinosaur asteroid was, so it will definitely cause more than just some small tremors. There's potential for it to even affect tectonic plate movement and cause more disasters. If ETM ends up falling with the pointy side down, it could have the potential to puncture through to the crust or at least do more damage.
Thank you, Fred. Truly a blessing to have you on today. Now, we'll be getting onto what we're going to do in order to stop all that from happening. I think we've scared everyone enough, don't you think so, Fred? We'll be talking about solutions for ETM, so join us in just a bit right after this short commercial break. See you in a bit!
His first law explains that objects in motion or at rest stay in their state of motion or motionlessness unless acted upon by an unbalanced force. His second law is the formula for force. F equals ma, or force equals mass times acceleration. His third law states that for every action, there is an opposite reaction. These are parts of the fundamentals of how our world works, how everything operates. This is what I hope to pass on to everyone around me, to anyone who's willing to learn. And that's why I make courses on ShareSkill. With ShareSkill, knowledge can reach anyone. Subscribe and explore the countless classes for countless things that ShareSkill can offer you.
Alright everyone, we are back. We just finished talking about ETM, the asteroid, and what it could cause. If ETM hits, the Earth will be at risk of mass extinction all over again. Other natural disasters from tectonic plate movement and other disasters like forest fires and tsunamis. We are now moving on to how we're possibly going to stop all those bad things from happening. Of course, there's no saying that these solutions will all go according to plan. So Fred, I'm new to this topic. Can you tell me a little bit about what we're going to do about ETM?
Gladly. So, we created a simple little experiment by recreating the situation by putting a marble on a track headed for a stack of pennies. The marble represents ETM. The track acts as ETM's trajectory, and the stack of pennies represents Earth. We build a wall in between the track and the pennies to see how well that will work. When the marble hit the wall will get pushed into the pennies to cause damage. We did a second attempt by building a rope attached to the track. The marble will jump over the higher area, but no damage caused.
In any proper experiment, there are three types of variables: independent, dependent, and control variables. Control variables are the elements of an experiment that remain the same throughout the entire thing, no matter what you change in between trials. Independent variables are the elements that you do change with expectation of a different outcome. The dependent variable is the outcome that occurs based on the changes or lack of changes in the independent variables. In this particular experiment, the track, the marble, and the pennies are the control variables. The track is the same length and the same height. The marble is the same one with the same weight. The same pennies are used and the same amount is maintained. The independent variable is the method of prevention, aka the wall and the ramp. Finally, the dependent variable is the damage inflicted to the stack of pennies, which will vary depending on how effective the independent variable is.
The ramp, as there's nothing to latch it to in space. There's no track in space that we could attack it to. But what we did gather is that the best course of action is probably to somehow change ETM's trajectory altogether. But how do we do that? Wanna take a shot, John?
I mean, sure, why not? So change ETM's trajectory, right?
Yes.
What if we send something to collide with ETM before it reaches Earth? Wait, let me think. Newton's third law. Does it have to do something with this? I'm a little out of practice in science things. So what if we send something to bounce the asteroid away? Something with an equal amount of force to counteract ETM.
You know what? That's pretty close. Closer than I thought.
Oh, really? Wow.
So, we could send something with an equal amount of force to collide with ETM before it reaches Earth. ETM trajectory wouldn't change though. Instead, it would explode and the multiple smaller pieces would fall to Earth, the damage resulting from which is a whole other conservation. Instead, what we think would be most effective is instead of sending something to hit ETM head-on, send something to hit it from an angle. Not only will this require less force, it will also minimize the explosion, and instead of shattering the asteroid, it will, in best case, send it far enough away to enter a different mass's gravitational field. Sounds simple, but there are actually a lot of criteria that need to be met in order for this to work properly. First of all, when we launch things into space, things don't just go away from Earth in a straight line. They curve around like an object in orbit, so in order to hit the asteroid, we have to calculate exactly when to launch the object so that their paths line up perfectly. Along with that, we need to make sure that the object is launched with the right amount of force. There needs to be enough force remaining when the object gets to ETM. When objects are on their way out of our atmosphere and making their way to where they are going, they don't lose force after they exit the atmosphere. They just maintain whatever their momentum was when they left the atmosphere.
You said that a certain amount of force needs to be applied. But what happens if the amount of force is excessive? What happens if by the time our object hits ETM, there's still too much force?
If the object we send collides with ETM with too much force, even from an angle, we risk shattering the asteroid, causing the same result of sending something to collide with the asteroid head-on. However, to bring out that result, it will take a lot of excess force and will be hard to achieve on accident. This whole collide ETM with something of equal force is a good example of Newton's third law of motion.
So Fred, thank you so much for joining us today. Hopefully, we'll be able to get you back on again soon and have you teach us some more.
If my schedule can make some time, haha.
Oh, of course. Wouldn't want to disturb you, wouldn't you? That was SCBCNS, your scientific collaborating broadcasting circle news segment, and my name is John. Join me in again at 7 a.m. tomorrow and listen to us to discuss the unsolved mystery. Who's Candace?
Okay. Wait. I made so many mistakes.
Yeah，我跟你说，就是你一点完那个，
我
你就要先
只是会一直忘记嘛，所以我说你按呢。
妈妈一说你一点完这个，对不对？你就要把浮标移到它，所以等到轮到它，你就
Yeah,
只
but
要
I
按
keep
就好。
forgetting to.
我很累。
Me too. I don't want to do it again. We have to do it again.
好累哦。